In this video, we'll be diving into natural language processing, NLP, where we'll explore how machines can understand and generate human language, covering key concepts like tokenization, embeddings, and named entity recognition, and how to build NLP models in Azure from scratch. From the previous session, we discussed deep learning and learned how to build and optimize deep learning models using Azure ML, including training models, tuning hyperparameters, and evaluating performances. Today's topic builds on that foundation. So if you haven't watched it yet, I encourage you to check it out for better context. Now let's get started and learn.
Natural language processing, or NLP, is a field within artificial intelligence focused on enabling computers to understand and work with human language. It allows machines to read, interpret, and even respond in ways that feel natural to us. You would find NLP in tools like virtual assistants, chatbots, sentiment analysis systems, and translation apps, helping bridge the communication gap between humans and machines. Some of the use cases for NLP include sentiment analysis for customer reviews. Businesses often receive thousands of customer reviews every day. Going through them manually would take too long. With NLP, reviews can be automatically labeled as positive, negative, or neutral. This helps businesses quickly understand how customers feel about their services and make informed improvements. 2. Email spam detection. NLP helps email systems like Gmail automatically detect spam messages. By analyzing email content for certain keywords, phrases, or unusual patterns, NLP can easily classify emails as spam or not. This reduces the risk of phishing and keeps unwanted messages out of your inbox. 3. Chatbot assistants and virtual assistants. NLP powers chatbots and virtual assistants like Siri, Alexa, and Google Assistant. These systems understand spoken or typed queries, detect the user's intent, and respond naturally. All this happens with the help of NLP. Many businesses also use chatbots to assist customers with basic services like checking account balances or answering frequently asked questions. Another use case is text summarization. Text summarization uses NLP to condense long documents into short, yet meaningful summaries. This is especially useful for news, legal documents, and research papers. For example, Google News summarizes articles so users can quickly get the main idea without reading the entire story. And there are so many more chatbots that allows for text summarization, and all these chatbots also make use of NLP. 5, we have speech recognition. Speech recognition converts spoken words into written text, combining NLP with audio processing. It's commonly used in voice assistants, transcription apps, and video captions. A good example is YouTube's automatic captions, which transcribes speech in videos to improve accessibility for all users. Now, looking at key concepts in NLP, starting off with tokenization. So what's tokenization? Tokenization is the process of splitting text into smaller parts called tokens. These tokens can be words, characters, or subwords depending on the problem. For example, the sentence Azure ML is great can be splitted into Azure as a token, ML as a token, is as a token, great as a token, and the exclamation mark is also a token. Tokenization is the first step in text processing because machines can't directly work with raw sentences. Rather, those sentences need to be clean, structured pieces such that the machine can analyze it. Another example is I love learning with Data Science Nigeria. This is a sentence However, if this is to be tokenized, it's going to be I as a token, love token, learning token, with token, data token, science token, Nigeria token, and the full stop is also a token. And this always serves as our basis during text processing for NLP. 2, we also have a key concept known as embeddings. Embeddings are numerical representation of words in a continuous vector space. Instead of representing words as simple IDs or one-hot vectors, embeddings place similar words closer together based on their meaning. For example, happy and joyful would have similar vector values because they mean the same. Techniques like Word2Vec, Glove, and modern models like BERT generate these embeddings. They allow machines to capture both the meaning and the context of the words being used in a sentence. And next we have stemming and lemmatization. Both are methods for reducing words to their base forms. Stemming cuts off words endings using simple rules, e.g., running becomes run, flies become fly, it's fast but not always accurate. With lemmatization, it uses a dictionary and grammar rules to convert words to meaningful base forms, not just cutting off the end of those words. Lemmatization tries to convert words to meaningful base forms. Better becomes good. Running becomes run. It's slower but produces correct root words. These two processes help reduce the number of unique words in a dataset, making the models more efficient. In NLP, we also see concepts like bag of words. Bag of words is a simple way to represent text by counting the number of times each word appears, ignoring grammar and word order. For example, both ML is great and great ML is would have the same vector because they contain the same words. While easy to use, bag of words doesn't capture word meanings or relationships, which limits its usefulness for complex tasks. We also have named entity recognition. Named entity recognition identifies the important pieces of information or entities in text, like people's names, places, organizations, or dates. For example, in the sentence, Microsoft is hosting an event in Lagos. Named entity recognition would label Microsoft as an organization and Lagos as a location. This is useful in applications like search engines, content tagging, and news summarization. Then we have part of speech tagging. POS tagging assigns grammatical labels to each word in a sentence, like noun, verb, adjectives, etc. This helps machines to understand how words function within a sentence. For example, in dogs run fast. Dogs is a noun, run is a verb, and fast is an adverb. It's useful in grammar checking, text analysis, and syntactic parsing. Then we have one of the most used concepts in NLP, which is stop words removal. Stop words are very common words like the, is, and. In many NLP tasks, these words don't add useful meaning and can be removed to simplify the dataset and reduce processing time. However, for some tasks, especially like advanced models like BERT, it might be useful to keep them because they can carry meaning in certain contexts. Removing the stop words helps in reducing dimensionality and improving computational efficiency in NLP tasks. So if you have a dataset with 5,000 words, possibly after removing the stop words, you should have around 450 words, 4,500 words, or 4,000 words. Now we're going to be building, training, and deploying an NLP model on Azure ML Studio. And this process includes data preparation, feature engineering, model selection, training and evaluation, and finally deploying those models. So let's see how we can do this on Azure ML. We'll be building an NLP model using Azure Machine Learning. I'll be working with the IMDb dataset from Kaggle to perform sentiment analysis. I'll take you step by step through data preparation, text processing, model training and evaluation, all within Azure ML. To start with, we head over to our designer and we click on Create New Pipeline. We rename this pipeline to NLP pipeline, save, and now we're good to go. We'll be making use of IMDb datasets from Kaggle. The dataset has two columns. That's the review column and the sentiment. So you have the column that has the movie reviews, and if that review is a positive review, we have it as positive, while if it's negative, then we have it as negative. The dataset has 50,000 entries, 50,000 rows, and we'll be using this dataset on Azure ML to perform an NLP, to build an NLP model and evaluate that particular model to see how well it performs. So let's go ahead to download this dataset. You download the zipped file and extract it. Immediately after extracting, though I've already done this, after extracting, then you need to save it on Azure Storage. As we all know, to import a dataset, you use the import dataset component. We'll pull this onto our canvas. To import the dataset, it's best we save the dataset on Azure Storage. So I'm going to head over to Azure Storage, go to my storage account. So on your storage account, access your account and upload the dataset onto a folder there. So I have a folder I've named NLP, and inside I have a folder named data, and here I have my data uploaded here. So please go ahead and do the same. Once you've done that, now you can access, import your dataset. To import our dataset, first of all, we have to have two things selected. Number one, is our dataset through a URL or a data store? This time around is through a data store. Then we need to select what data store exactly do we want to get our data from. So we've created several data stores before, which we've learned how to make use of. So I'm just going to select one of those data stores. If you're not sure what a data store is and how to create one, please watch the videos that we've created before now to learn how to create a data store. So we're going to browse through our data store. This should take us to basically to our storage. So we're going to be using the Azure ML data store. This should take us to our storage, okay? And here I can access all the files that I have on my storage account. So I'm going to select NLP data, and I'm going to click on this dataset. So since the dataset is stored here, I can just save this path. As I've saved this path, then I should be prompted to see what exactly is inside here. That's the IMDb dataset. I should be able to preview to see the schema. Here we have the review and the sentiment as the two columns in our dataset, and that's perfectly fine. Beautiful. I'm going to be making use of a completed pipeline so that I can show us the outputs, how it looks like, for better understanding. So going back to our imported data, while this is loading, our imported data has 50,000 rows and 2 columns. However, this is really huge. If you do not have a huge computing power, then definitely you're not going to be able to run this on your subscription. So to limit the compute resource that we'll be using, we're going to select 1,000 rows from the 50,000 rows that we have. Okay, to do this, you're going to be making use of the partition and sample. So we have a component named partition and sample. This component allows you to select specific rows from your data set. So we're going to pick this and drag onto our canvas, and we're going to connect our data down here. So with the partition and sample now, we are able to configure this. So you have three things, 3 or 4 ways to get to partition and sample, but we'll be going with the head. This allows us to select the top part of our data set, and now we just have to specify the number of rows we want to select. Okay, so we are selecting 1,000 rows from the data set right here. With this we are fine. So it means with everything we're doing now, we're only going to be making use of the first 1,000 rows from the data set. I wanted to also show us the completed pipeline so that we're able to follow through. The imported data sets here, let's preview the data. The data set we just imported right now has 50,000 rows and 2 columns, like you can see here. While what we just did right now is to partition and sample. After partitioning, the result should look like this. Now you have 1,000 rows and 2 columns. So this is a run that has already completed. So we're going to be using this so that you're able to follow how the output would look like for each and every step that we're going through. Now we've partitioned and we're only selecting 1,000 rows so that we minimize the use of our compute resource. However, if this is the deployment level pipeline, then it's best you have the resource that can process the 50,000 rows of data. Now, next, if you do notice from our data sets, we have the sentiment column has entries like positive, negative, and then these are text. However, we need to ensure that this positive and negative we have here are converted to 0 and 1. We convert sentiment to 0 and 1 in NLP for binary classification, making it easier for ML models to process. It enables numerical computation, optimizes classification algorithms, and supports probability-based predictions. So we have to do that right now. To take care of that, how do we approach it? To take care of that, we're going to be making use of our edit metadata component. So we drag the edit metadata component onto the canvas. And what we want to do is to make use of this edit metadata component to select what column we want to, the column that we want to perform transformation on. So I'm going to configure this. We're going to be selecting the column that we want to make changes on, and that's the sentiment, not the review. So we're going to say sentiment, and we're going to have this and say save. Fine, so we've selected this. However, what do we want to do? Are we changing data types? No, we're not. Categorical, yes, we want to make this column a categorical column. Fields, no, we're not changing anything here. This is fine. We're not changing the column name as well. Then this is good. So what we really want to do, however, is to apply transformation. So we want to apply transformation to change positive to negative. So we're going to be making use of apply SQL transformation. So we drag this and we drop this right here. So let's configure this. This component can take up to 3 data sets. To configure this now, you just need to write a script that you want to perform on the data set. Whatsoever transformation you want to do on that particular column, you can just go ahead to do those transformations. So we edited our metadata and we made that column categorical. That's fine. Next, we want to ensure that anywhere, for any case when we have sentiment as positive, we want to change that positive to 1. And when we have the sentiment as negative, then it should be 0. We want to save this as sentiment encoded. That's what we want to save the name of the new column as. And what we're performing this on what? We're performing this on our first input, which is T1. With this, we're good and fine. Next, I'm going to connect the results data set from our edit metadata, where we categorize the sentiment column and pushing it down to this component. After performing this process, the result of this process is going to be 3 columns. This should be the review, the sentiment, and the sentiment encoded. Just so we find out, we come down here under apply transformation. Let's look at the results we have here. So you're going to have the review, the sentiment, and the sentiment encoded. Positive 1, positive 1. Anyone that is negative should be 0. That's the output we expect when we are here. Okay. Now, we need to drop a column. What column is that? That should be this sentiment column, because we do not need it anymore. What we need is the sentiment encoded. So to do this, we are going to select columns in datasets. We use the select column in dataset to select particular columns that we're interested in. So we're going to drag the select columns. We're going to drag select columns in dataset, not select columns in columns transformation. And here we're going to configure this by double clicking. What columns do you want to select from the existing data? I want to select 2 columns. We want to select the review. Here, want to select the review, comma, sentiment encoded. Sentiment underscore encoded. That's what we named. Yes, so that's what we have named the new column, right? So we're dropping sentiment, fine, and we save. Then we connect the results from our transformation down to this. With this now, we would have an output that looks like this. After applying transformation, you have an output that looks like this. Let's preview the results. The results should just be the review and the sentiment encoded, just like this. Okay. Now let's go back. So next, we want to now start to work with our text data sets. What we have done up to this level is to import the data, partition the data by picking just the 1000 rows, the first 1000 rows. Next, we edited the metadata to ensure that the column is, we change the data type to a categorical column. That's for sentiment. Then we apply transformation to convert the text to binary columns, zeros and ones. Next, we dropped the column that had the positive and the negative sentiment off so that we have just the review and our encoded sentiment. That's what we have done up until this point. So when working with NLP, we use what we call the pre-processed text. We need to, it's way different from when you're trying to work with numerical variables, or you're trying to work on problems that has to do with quantitative data. This time around, you're working with qualitative data and you're trying to actually pre-process sentences, paragraphs, essays, you know. These are texts that are being given. You need to be able to pre-process those texts. So we use a component called the pre-processed text. And this component is actually really powerful. It allows you to do a lot. The first thing you get to do is to select a language. What language is that text on? Here, select the language to be processed. Currently, Azure ML is capable of handling English text. Then, do you want to expand verb contractions? This converts contractions like don't to do not. I am to I am. Okay, to their full form for better clarity and consistency across. Then we have the remove stop words. This eliminates common words like and, the, is. These are common words that we use, and they do not really give add any value to what you're trying to do right now. So you could decide to remove stop words. Next, use lemmonization. This converts words to their base or dictionary form, e.g. running becomes run. Better becomes good. Okay. Then detect sentences. This identifies sentence boundaries, useful for downstream NLP tasks like summarization and sentiment analysis. Normalize case to lowercase. It converts all text that you have to lowercase to ensure consistency and avoid duplicate representation of words. There could be particular parts in your data set that we spell Python with capital P, YTHON, and some parts could be spelled as small p, y, thon. So for consistency, you could decide to use
normalize everything to lowercase. Remove numbers, just like it states, it eliminates numerical values that do not contribute to the text except when relevant. Then we also have remove special characters. This removes symbols like at, hash, dollar sign, percentage, ampersand, and things like that. We also have remove duplicate characters. This reduces repeated characters that may arise due to misspelling or emphasis. Maybe, for example, in your text, you have somebody spell good as maybe, because these are movie reviews. Possibly somebody really enjoyed the movie and then they send a review as I love this movie. Okay, you can see that the L has so many L's in it, maybe possibly 5, 6 L's. It has been typed just to emphasize the love they have for the movie they just watched. Removing duplicate characters reduces this repeated characters. So that love that was typed is not going to be just love. Okay. Then remove email addresses. Just like it states, it deletes email addresses to clean up the text. We also have the ability, preprocessed text allows us to remove URLs, normalize backslashes to just slashes, and to split tokens on special characters. This breaks words apart when separated by special characters. E.g., hello-world becomes hello, comma, word. Okay, so this that's what the split tokens on special characters does. Then custom regular expression allows defining specific patterns for text cleaning using regular expression. So we're going to make use of this as well. Then lastly, we also have text column to clean. This specifies which column in a dataset should undergo the text pre-processing. So with this, we have an understanding of what the capabilities of the preprocessed text has. So we're going to have this to be true all across. We're expanding verb contractions, removing stop words, we're using lemmanization, we're detecting sentences, and all of this we're going to set to true. Now, custom regular expression. Why do we even need to specify anything into custom regular expression? Not because it's something that you always do, but it's something that you do based on need. If you look at this data set, you would notice we have line breaks, which are HTML tags. Expanding this, we have this line breaks, which are not really what we want. We want to take care of this line breaks across. They do not add any meaning to this data set as we're trying to build this NLP model. So we need to take care of them. So to take care of them, we have to make use of this custom regular expression. So here we're going to pass in this. So what we're trying to do here is to say that, you see, from here down here, this takes care of all HTML tags, line breaks, paragraphs, div, and all HTML tags. We take care of them using this. Then we'll take care of any special characters using this. Okay, special characters like square brackets, parentheses, periods, single quotes, double quotes, forward slashes, percentage signs, and things like that. So what do we want to replace all of this? When we see any of this, what do we want to replace them with? We want to replace them with just a space. So I'm going to hit the space bar once. So here there's the space there. So anywhere all of this are being found, it's going to be replaced by just a space. Then which column is this going to be applied onto? Looking back at our data sets, we are applying this onto, let's take a look at the output here. We are applying this not onto the sentiment encoder, but rather onto the review. So we're going to specify that this replacement should happen on the review because it's the review that has those line breaks and special characters. So we're going to come here and we're going to say edit column, and I'm going to enter, apply this on the review column, and we're going to save. With this, we are good. Next, connect the selected columns down in here. If you have specific stop words, you could connect them in here. Okay. So with this, we have now successfully preprocessed our text. We imported the data. partitioned the data, edited the data set, applied particular transformations, select the data, the columns that we're interested in, pre-processed the column that needs to be cleaned. At this point, our data is clean. Next, we're going to split the data set into test and train sets. So we're going to use the split data component here, and we are going to configure this. So we could decide how we want to split the data set. So we're going to stick to 80% training set and 20% test set. With this, we are good, and we're going to close this. Connect your pre-processed text down to the split data set. The next step is to extract n-grams. So we're going to drag extract. We're going to drag the extract n-grams component. The extract n-grams component, we do this after splitting the data to ensure that the feature extraction is done only on the training set to prevent data leakage. This allows the model to generalize better on unseen data. And we all know what extracting n-gram means. It's a process in NLP where sequences of n consecutive words. N here means 2 consecutive words, 3 consecutive words, 4 consecutive words, 10 consecutive words, depending on the number of n that you want, depending on the number of consecutive words that you want, are extracted from text to capture context and improve model performance. So if you have a sentence and then maybe you're working on 3 grams, so we call it trigrams. When you select that you want to extract your n-grams on the 3rd level. So in a sentence, words like love to dance, love to work, love to sleep are going to be extracted. So we'll go ahead to connect the the first dataset, which is our training dataset, to our n-grams, and we're going to then configure the extract n-gram features from text component. So first things first is to select the column where you want to perform this particular activity on. We're performing this on the review column, not the sentiment encoded, the review column, and then we save. Next is the vocabulary mode. The vocabulary mode determines how the vocabulary, which is a set of unique words or phrases, is created from feature extraction. Okay, here. So like it states here, it specifies how the n-gram vocabulary should be created from the corpus. So if you set this to create, it means the vocabulary is generated from the input text data. That's from the raw data. You want the vocabulary to be created for you. But if you set this to read only, it means you already have an existing vocabulary and you want that existing vocabulary to be used, ensuring consistency across different data sets. Since we're connecting to our raw data set, we're going to be creating our vocabulary from scratch. And next is the n-gram size. The n-gram size indicates the maximum size of n-grams to be created. If we set this to, so we're going to select 3. Setting this to 3 means we're going with trigrams, and with trigrams it means the maximum number of n-grams is going to be 3. So maximum number of combinations can be 3 words. So when you select 3 as your grams, as your n-grams, it doesn't mean you're just going to get words that only 3 words are going to be combined. Rather, you're going to have bigrams and unigrams as well. So it's going to split them into maximum of 3 and the minimum of 1. So you're going to have 2 words combined, and then you also have the maximum of 3 words combined. Next, you have the weighing function. These are ways to give importance to words, in brackets, n-grams, right, in a document. Here you have 4 different weighing options or weighing functions that you could select from. The binary weights, with the binary weight, if a word appears in a document, it gets a 1, but if it doesn't, it gets a 0. So it just checks if the word is there or not. While for the TF weight function, also known as the time frequency function, counts how many times a word appears in a document. More frequent words get higher scores. While for the IDF weight, which stands for inverse document frequency, it gives more importance to rare words and less importance to common words by considering how often a word appears across all documents. Then we have the TF-IDF. which is a balance between the TF with the time frequency and the inverse document frequency. It balances with it between the two. So we're going to be selecting TF-IDF. The minimum word length set to 3 ignores words shorter than 3 letters. The maximum word length set to 20 ignores words longer than 25 letters. While the minimum n-gram document absolute frequency, with this, it keeps n-grams that appear in at least 5 documents. As this is set to 5, we're going to leave it as default. The maximum n-gram document ratio with the value 1, it means it includes all common n-grams. Lastly, we get to set to either normalize n-gram features or not. Why do we normalize n-gram features? These are just values so documents dominate. So therefore, we're going to set this to true. So with these configurations, we're now good with extracting n-grams features from text, and we're going to close this off. Perfect. We have completed setting up this component for the training set. However, we also have to do the same for the test set. So I'm going to copy and paste. And for the test sets, these are our test sets. We're going to connect it to the data set here. Fine. Next, the input vocabulary. Since we are creating the vocabulary here, we do not need to connect this. However, for the test set, we want to maintain the vocabulary that has been created by this component. So we're going to pick up, here you have the results data set, while here, this is the resulting data set, okay? While here, this is the result vocabulary. So I'm going to pick this vocabulary and have it connected here. Now, what we need to change in this component is to change it from create to read only, because we are reading a vocabulary that has been created by the training set. This ensures consistency across. We are fine now. With this, now we can go ahead to train our model. Like we've always done, to train our model, you pick up the train model component, drag it onto your canvas, okay? And then you connect the data set from your training set to your train model. Now, what's left with the train model is the algorithm that you want to use. What algorithm are we going to use? We're going to be using the two-class logistic regression, which is best for binary classification, and we're going to connect this down here. Fine. So we've not configured any of this. So let's look at the train model. What are the things that we need to select? With the training model, we need to select what our label column should be. What are we trying to, what's our target column? And our target column is our sentiment encoded. Sentiment underscore encoded. So we're going to have this and say save. Model explanation, if we want to say yes, if we do not want to say no, so I'll just keep it as false. Or better still, let's have this as true, so that our model is going to be explained to us. Then with the two-class logistic regression, we're going to be sticking to the default parameters that we have here, and I'm going to save. So up until this point, we have cleaned our data set, pre-processed it, split it into training and test set, and we have performed our n-gram extraction. Then we have trained it. We're training the whole model on a two-class logistic regression algorithm. After this, next step is just for us to score our model and then evaluate the model. We all know how to do this from our previous videos. You just need to pick up your score model component and have your score model component onto your canvas. It takes in two inputs, the train model and your test dataset. So we're going to drag our train model and connect it here. And then we're going to pick the result from the test set down here, so that that can be tested and scored. Afterwards, lastly, for every machine learning algorithm, you need to evaluate that model. So we're going to be evaluating the model by dragging this and having this onto the canvas. How do we connect this? It takes in a maximum of 2 inputs, so we're only passing down this code model for it to be evaluated. I'm going to clean this space, and we're going to just have another look at our pipeline. So let's make this cleaner. Let me go back in here. Yes, so we have more space now. Let's zoom this in. We started by importing our data sets where we had our data on Azure Storage Blob. Then we created a data store and we pulled our data in. Next, we selected the first 1000 rows and then we edited our metadata by making the sentiment column a categorical column. We applied specific transformations to transform positive text to 1 and negative 2 value 0. Then we selected the columns that we're interested in, which is the review and the sentiment encoded. We pre-processed our text, taking care of our stop words and special characters. Then we splitted the data into test and training set, 80% training and 20% test. Then we performed our n-gram extraction where we had the settings for this component and we connected our training to our n-gram extraction components. Here we created our vocabulary, while for the test set we used the vocabulary already generated by our training set for consistency across. We trained our model on 2-class statistic regression, scored the model, and then evaluated the model. So with this we are good to go. Next is just for us to configure and submit this experiment. Like we've always done, you just need to click on configure and submit. Okay, and then we're going to create a new, so I'm going to name this NLP underscore experiment. Let's say, okay, then we need to, this was not saved, so NLP underscore pipeline underscore experiment. So let's have it as this. Okay, why is it not saving? Oh, we are still on selecting existing. We want to create a new one. So NLP underscore pipeline underscore experiment. So let's just save it as this, and then job display name NLP pipeline, let's say tutorial. Then we need to specify input and output to a good runtime settings. We need to select our compute, so we're going with a compute cluster, and we are sticking to our ML cluster here, this one. Then with this we are good, we're sticking to the default data store, and that's totally fine. Review and submit, this is fine, and we're going to go ahead to submit this. We're going to monitor the pipeline. I'll close this. Immediately it has submitted. We're going to monitor the pipeline to see how this performs. It has successfully imported the data. It has picked the head. It has edited the metadata. It's now applying transformation. When this is completed, it's going to go through the whole process. So now we have a complete pipeline run from data importation down to evaluation. So let's look at the metrics, and
Let's just try and interpret what we have. I'll double click on this and I'm going to expand this. Let's take a look at the metrics. What do we have? So the NLP model is doing pretty good job. It has an AUC of 0.854, which means it can correctly distinguish between the two classes 85.4% of the time. That's a solid performance. Now let's look at the key metrics. The accuracy is 75%. This means the model is correct 75% of the time, with precision of 74%. Out of all the time the model predicted positive, it was right 74% of the time. Recall is 74% as well. Out of all the actual positive, the model successfully found 74% of them. With the F1 score of 74%, this balances the precision and recall, so we know the model isn't favoring one too much. Now, looking at the confusion matrix, this chart does not do justice to the confusion matrix. We might decide to look at a different view of the confusion matrix. But looking at the confusion matrix, we can see that the model misclassified 25 cases here. Okay. Then it misclassified 25 cases as false positives and 25 as false negatives as well, here and here. That means it sometimes predicts positive when it shouldn't, and sometimes it misses real positives. With the ROC curve, the ROC curve looks actually good here, showing good model performance, and the precision recall curve helps us understand how well the model works at different thresholds. So with this, we now know how to build an NLP model and how to also evaluate an NLP model. With the confusion matrix, I think a better visualization is this visual right here. This actually does justice to it. So we can as well adjust the threshold and see how this false positive and false negatives actually change across. So congratulations, and this is how you build an NLP model on Azure Machine Learning Studio.
Well done on completing today's class. Let's quickly recap the key points we've covered. We explored natural language processing, focusing on how machines pre-process human text. We discussed essential concepts used in NLP and went further to build and evaluate an NLP pipeline using Azure Machine Learning Designer. A memorable takeaway from today's session is that you can easily pre-process text and build models using Azure's drag and drop interface. This is something you can start applying right away. To ensure you're engaged and practicing, I've prepared an assignment for you. The goal is to help you build a text classification pipeline in Azure ML, applying the skills you've learned today. And your tasks are as follows. 1. Download the SMS classification using NLP dataset from Kaggle. This dataset would also be provided to you. Build a text classification pipeline on Azure ML Designer that includes 1. Text cleaning and pre-processing, splitting the data into 70% training and 30% testing sets, extracting features using n-grams, and training a classification model using two-class logistic regression. And the third task is to evaluate this model. Upload your completed assignment to the learning portal. The full assignment details would also be provided there. If you encounter any challenges, don't hesitate to reach out to your teaching assistant for support. You can also engage via Google Classrooms for additional guidance and clarification. Thank you for being an active learner in today's session. Keep pushing your boundaries, and I look forward to seeing your progress in the next class. See you soon.